Hi, my name is Thomas Kim. In this session, we will generalize Euclidean algorithm. In my previous session, I elaborated about Euclidean algorithm and how to implement it, and also I explained the theory behind Euclidean algorithm in my previous video. If you haven't watched my previous video, please watch it. I will put the link down below. To follow with me, you have to understand my previous video. So to recap my previous explanation about Euclidean algorithm, I will let now three numbers A, GA, B, GB, and I will introduce another number C, like GC, like this. We now have three numbers. I will recap my previous video first. In Euclidean algorithm, GCD, before I say this, I have to mention A and B and C are co-prime. Okay. Here, Euclidean algorithm is something like this. If B is greater than A, then we swap A and B. Second, GCD A and B equals GCD B A modulo B. This is our previous session. If this term becomes 0, we will apply this rule repeatedly. If it becomes 0, then GCD becomes B prime 0. Then B prime is G. This is what I explained in my previous video. Now in this session, we are trying to get three numbers. G greatest common divisor of three numbers. How we can do that? So before I explain that, I will remind you one thing. GCD A and B equals GCD B and A. We can swap the order. We can change the order like this. So if we examine the three numbers, we can say if we apply this one first, GCD BC will give us G. We follow this way. See, B, B, G, B, C. The greatest common divisor would be G and would be G. Now, if we want to get GCD of ABC, then we apply like this: GCD A and GCD BC. Then we have to evaluate this. Then it will be GCD A. Then the result of this is G. Then if we put GCD, A would be GA, G. If we apply this rule, then it becomes GA modulo G. Then it becomes 0. Then the result would be G. So this way we can evaluate the three numbers. So if I generalize it for three numbers, GCD of A, B, C equals GCD A, GCD B, C. This is the way we calculate three three numbers. The greatest common divisor of three numbers would be calculated this way. If we have four numbers, for example, A, B, C, D, if we have four numbers, we can calculate like this. GCD, A, GCD, A, B, C, D. We will calculate like this. Then using this rule again, GCD, A, this rule, GCD, B, GCD, C, D. We calculate this, then we calculate this, then we calculate this. This way is actually recursive. I will code it in C++. We will use Variadic template. I explained about Variadic template in C++ in some videos. I will put the link down below. So if you don't know about Variadic template, please watch it. So in previous video, we explained GCD of two numbers like this. For GCD of two numbers, int, GCD of two numbers, int, A, int, B. If A and B greater than A, then we swap A, B. Then here, then int, G for example, then while G equals A modulo B is not 0, A equals B, B equals Z, and here return B. This is in two numbers case. This is what I explained in my previous video. I will make it like this. Return. So this way, this is in case of two numbers, GCD of two numbers. This is the code we have done in my previous video. Now we have three numbers, so we can do like this. Now we have three numbers, int, A, int, B, int, C. We have three parameters. Now we can say return GCD A, GCD B, C. Because it calculates, if we call this function with three numbers, it calls this function and it returns result G, for example. Then A and B equals again, then it returns the result. This is we generalize. This is in three cases. if we want to generalize it, we have to use periodic template like this. I will implement it using in periodic template now. Using periodic template, type name, T GCD, I would say constant, T reference A, constant, T reference B, here I would say int, A equals A, B equals B. The rest is the same as before. If B greater than A, we swap. Okay? So the rest is the same. int, G, while G equal A modulo B is not 0, then A equals B, B equals G. Then here we return, we have to return B. So this is the template case of two arguments. Now here we are using periodic template. Now we are using periodic template, another function we are making. It's very simple. Here, like this. Template, type name, T, type name, 3 dots, ellipsis, three ellipses, then T, I would say TARG, then T GCD, here constant, T ampersand, A, here constant, TARS, this TARS, ampersand, 3 dot, then ARGS. This is parameters. Then here, then it's very simple. Return GCD, here A, and GCD, this one, ARGS, 3 dot. Then this is simple. So this function calls pause this parameter to itself again and again until it becomes 2 arguments. Then it becomes 2 parameter. Then this function will be executed. Then if it returns, then finally it executes again. so that we can get the result. This way, we can generalize a Euclidean algorithm. This is our previous session, our solution from our previous session. I will recap my explanation. For three numbers A, GA, B, GB, C, GC, GCD, A, B, C equals GCD, A, GCD, B, C. This is the way we do calculate three numbers, GCD, greatest common divisor of three numbers. Here we will implement it like this. Template, type name T, GCD, constant T, A, constant T, B, if int A, B, B, if A, B greater than A, then swap AB. Here int R, I would say R, while equals A modulo B not 0, then A equals B, B equals R. Here we return R. Then we need another one, template, type name T, type name T args, T GCD, constant T A, constant T args, here return GCD A, GCD args. So this way we can calculate three or more numbers, GCD of three or more numbers. I will disable it for the time being. We will test it. GCD 3 times 7, 3 times 5. We will try with two numbers first. Now let's run. This gives us wrong answer. Sorry, I made a mistake here. It should be B. And it should also be T. And it should be T. Now let's try again. Okay. Now it works. Now we will try another. I will put one more numbers like 11. We should still have the value 3. Okay. Now we can have like this, int a 2 times 3 times 5, b equals 2 times 3 times 7, c equals 2 times 3 times 11, d equals 3 times 2 times 3 times, I would say 5, no, I would say 13, for example. Now if we say A, B, C, D, now we run it, the number is 6 because we put number 6 here. These are greatest common divisor. Now I will put here 5. Oh, actually I don't need 5 here. I will put here 5. And I will also put 5 here. Also here 5. Now let's run it. We should have 16, 6. We should have 13, number 30. Okay, 30. So this way we can calculate arbitrary number of numbers of GCD of arbitrary number of integers. This way. Say if you haven't watched my previous video about Variadic template, these are Variadic templates. This and this are Variadic templates. Please watch my video about Variadic template. In my next session of video, I will talk about least common multiple of numbers. Thank you for watching.